Hola, seniors and senoritas, are you and your dear and your safe and fit? It's activist come preacher, Professor S. Suresh, back with absolute delight for my 63rd video in process for publication on YouTube today, 17th of August 2020. Topic for discussion today is industrial plant site selection and appropriate plant layout types. Type. A unit is a collection of process and or manufacturing equipment that is focused on a single operation. A plant is a collection of process units with similar process parameters are related by feeding or taking feed from each other. A site is a collection of plants typically owned by a single entity. A site may have its own support facilities or share them with another site. Support facilities may include parking, offices, maintenance and warehouse facilities, firehouse, medical, transportation and security facilities. A complex is a collection of sites that may or may not be owned by the same business entity. A site within a complex may feed or take feed from another site within the same complex or be totally independent. A factory, manufacturing plant or production plant is an industrial site. Usually a complex consisting of several buildings filled with machinery where workers manufacture items or operate machines which process each item into another. They are a critical part of modern economic production, with the majority of the world's goods being created or processed within factories, industries. Industries can either be manufacturing or service or hybrid. Hybrid is a combo. Most modern factories have large warehouses or warehouse-like facilities that contain heavy equipment used for assembly line production. Large factories tend to be located with access to multiple modes of transportation, with some having rail, highway and water loading and unloading facilities. In some countries like Australia, it is common to call a factory site building a shed. Factories may either make discrete products or some type of continuously produced materials such as chemicals, pulp and paper or refined oil product. Factories manufacturing chemicals are often called plants and may have most of their equipment, tanks, pressure vessels, chemical reactors, pumps and piping outdoors and operated from control rooms. Oil refineries have most of their equipment outdoors. Discrete products may be final goods or parts and sub-assemblies which are made into final products elsewhere. Factories may be supplied parts from elsewhere or make them from raw materials. Continuous production industries typically use heat or electricity to transform streams of raw materials into finished products. The term mill originally referred to the milling of grain, which usually used natural resources such as water or wind power until those were displaced by steam power in the 19th century. Because many processes like spinning and weaving, iron rolling and paper manufacturing were originally powered by water, the term survives as in steel mill, paper mill, etc. Industrial site selection is a strategic decision that involves several criteria with consideration for technical, economic, social, environmental and political issues. These criteria are generally described using a number of different indicators expressed in quantitative and qualitative ways with some possible uncertainty. Decision making requires therefore appropriate tools to enable data collection, storage, analysis, fusion and knowledge management to address this complex, multifaceted scenario. Traditionally, industrial site selection has been based almost exclusively on economic and technical criteria. Currently, a higher degree of sophistication is desired in order to also satisfy a number of social and environmental requirements which may be enforced by legislation and government regulations. The industrial site selection process becomes, therefore, a complex, multi-criteria analysis which includes a set of criteria encompassing technical, economic, social, environmental and political issues, possibly resulting in conflicting objectives. The present-day analyst increasingly strives not only to satisfy all constraints but also to optimize various decision criteria which may be conflicting and to present a number of possible sites, each with specific advantages and limitations. Due to the complexity of the task, the industrial site selection process is divided into two phases. First is the macro phase macro location, and within this area the selection of micro location. The micro location is a geographical area, typically the size of a municipality, that meets the basic requirements for construction and development of the industry with a minimal operating cost. The micro location is a specific place within the macro location that meets technical, infrastructural and working process requirements. A number of decision support tools have been used to support the identification of the most possible suitable industrial sites, including Geographic Information Systems (GIS), Multi-Criteria Decision Analysis (MCDA), and Expert Systems (ES). Geographic Information Systems are mainly used to collect geographically specific data and support the location-based presentation and analysis. Multi-Criteria Decision Analysis has been extensively used to explore the space of the available solutions and identify the optimum selection in the presence of conflicting goals. The expert systems are often used to analyze the solution space by reasoning on the basis of the available knowledge. These tools have helped an important role in solving the site selection problem, but have limits in dealing with all relevant criteria and reaching the most suitable solutions. Recent developments in the field of decision making have led to dramatic improvements in the capabilities of GIS for industrial location analysis. These developments especially concern the analysis of attribute data and procedures for multi-criteria analysis. Unfortunately, MCDA, multi-criteria decision analysis methods, assume normalized data, which is difficult to achieve in industrial location problems where it is necessary to compare several quantitative and qualitative criteria in a highly imprecise and uncertain environment. To compare the various criteria in MCDA, data must be standardized in the appropriate range suitable for the analysis. To address all of the above aspects in an integrated way, we process a novel comprehensive method for industrial site selection, CMISS, which provides an innovative approach to decision making that mitigates uncertainties in the input data by combining various complex interacting decision support systems in a synergic way. Plant location refers to the choice of the region and selection of a particular site for setting up a business or factory. The choice is made only after considering cost and benefits of different alternative sites. It is a strategic decision that cannot be changed once taken. The location should be selected as per business requirements and circumstances. Businessman should try to make an attempt for optimum or ideal location. An ideal location is one where the cost of the production is minimum with a large market share, the least risk and the maximum social gain. It's a place of maximum net advantage or which gives lowest unit cost of production and distribution. Location analysis is a process in which analysis of alternate sites is done with the aim of selecting the best site for business. Various types of analysis are demographic analysis. It involves a study of population in the area in terms of total population, age composition, per capita income, educational level, occupational structure, etc. Site economics. Alternate sites are evaluated in terms of establishment cost and operational cost under this. Cost of establishment is basically cost incurred for permanent physical facilities, but operational costs are incurred for running business on day-to-day basis. They are also called running costs. Competitive analysis, it helps to judge the nature, location, size and quality of completion in a given trade area. Traffic analysis, to have a rough idea about the number of potential customers passing by the proposed site during the working hours of the shop. The traffic analysis aims at judging the alternate sites in terms of pedestrian and vehicular traffic passing a site. This is for shops, the service type of industries. Primarily, the plant must be located where the minimum cost of production and distribution can be obtained, but other factors such as room for expansion and safe living conditions for plant operation as well as the surrounding community are also important. The choice of the final site should first be based on a complete survey of the advantages and disadvantages of various geographical areas and ultimately on the advantages and disadvantages of available real estate. The various factors are raw material availability, location of market for distribution, availability of suitable land, transport facilities available, availability of requisite labor, availability of requisite utilities, availability of water, electricity, environmental impact and effluent disposal, local community considerations, climate, political and strategic considerations, taxation and legal restrictions. There are many analytical methods which can be used for selecting the suitable site for an industry. Factor rating is the most widely used method. Followed are the basic steps. Develop a list of relevant factors. Assign a weight to each factor reflecting its relative importance to the firm. Develop a rating scale for the factors. Score each location on each factor based on the scale. Multiply the scores by the weights for each factor and total the weighted scores for each location. Make a recommendation based on the maximum point score considering other factors. In factor rating method, first, we must identify the most important factors in evaluating alternate sites for the new facility. Then we should assign a weight between 0 and 100 to each of these factors. Each alternate location will then be rated based on these factor weights. The most weighted alternate is selected as the best alternate. The cost, complexity and safety of process operation and maintenance are highly dependent on site location and layout. Building inherent safety into a site generally reduces both the cost and complexity. Siting and layout are among the earliest steps in design and are quite costly to modify once a site is constructed. Optimum siting and layout minimizes material and construction costs, but most importantly minimizes the risk of losses throughout the site's life cycle. Location could either be in an urban area, suburban area or rural area. Besides, sometimes a plant could be located in a backward area, considering the subsidies offered by certain governments to develop such areas. One needs to weigh, consider the pros and cons of all the critical factors and then select the optimal location for the plant. Succeeding processes are based on the site selected, and it is practically impossible to change the site. Hence, due care should be exercised in site selection. You should not repent it later. Post deciding the location, the buildings, allied infrastructure should be planned. This depends on the product, services, facilities required for the same, like equipment, material handling system, landscaping, canteen, maintenance, warehouse, generators, etc. Plant layout is a mechanism which involves knowledge of the space requirements for the facilities and also involves the proper arrangement so that continuous and steady movement of the production cycle takes place. A plant layout study is an engineering study used to analyze different physical configurations for a manufacturing plant. Plant layout embraces the physical arrangement of industrial facilities. This arrangement, either installed or in plant, includes the space needed for material movement, storage, indirect labor and all other supporting activities or services, as well as for the office equipment and personnel. As per Richard Muther, plant layout is arrangement of machines, work areas and service areas within the factory. George Terry. Plant layout involves the development of physical relationship among building, equipment and production operations, which will enable the manufacturing process to be carried on efficiently, as per Morris Hurley. Plant layout is an arrangement of machines and facilities is layout according to Moore. Plant layout can be defined as a technique for locating machines, process and plant services within the factory so as to achieve the greatest possible output of high quality at the lowest possible total cost of manufacturing. As per Sprague and Landsberg, plant layout ideally involves the planning and integrating the parts of the component parts of the product to achieve the most effective and economic interrelationships between the operating equipment and personnel, the material movement, storage facilities, service functions and auxiliary equipment. As per Lundy. Hazard assessment of site layout is critical to minimize consequences of loss of containment and chances of escalation. The domino effect may be by fire, explosion or toxic gas cloud causing loss of control of operations in another location. Plant layout design techniques applicable to reduction of the risk from release of flammable or toxic materials include locating the storage of flammable toxic material outside process areas, locating hazardous plants away from main roadways through the site, fitting a remote actuated isolation bars where high inventories of hazardous materials will be released into vulnerable areas, allowing for the provision of dikes and sloping terrain to contain releases, increase the safety and reduce environmental effects, siting of plants within buildings as secondary containment, siting of plants in an open air environment to ensure rapid dispersion of minor releases of flammable gases and vapors and thus prevent concentration buildup which may lead to flash fires and explosions. Hazardous plant area classification for flammable gases, vapor and dust to designate areas where ignition sources should be eliminated. Plant layout and scheduling have a substantial effect on productivity. In many machine producing activities, neither the order of operation or the placement of machines is inherent in the process, nor is it physically difficult simply to stop the process and hold a partially finished piece at the workstation until it is again convenient to work on it. The arrangement of resources in a facility can significantly affect the productivity of a business. A lot of wasted time, energy and confusion can result from a poor layout. There are also other reasons layout planning is important. In many work environments such as office settings, face-to-face interaction between workers is important. Proper layout planning can be critical in building good working relationships, increasing the flow of information and improving communication. Similarly, in retail organizations, layout can affect sales by promoting visibility of key items and contributing to customer satisfaction and convenience. Layout planning affects many areas of a business and its importance should not be underestimated. The primary criteria for evaluating any layout will be minimization of material handling costs. Material handling costs are typically directly proportional to frequency of movement of material and the length over which material is moved. Principles of plant layout are principle of integration, principle of minimum distance, principle of cubic space utilization, principle of flow, principle of maximum flexibility, principle of safety, security and satisfaction, principle of material handling. Advantages of the criteria are reduction of idle space required, lower WIP, work in process or work in progress levels, lower throughput times, less product damage and lower obsolescence, reduced storage space, simplified material control and established scheduling, less overcrowding in system. Layouts can be classified into the following 5 categories. Process layout, also called as functional layout. Product layout, also called as assembly line layout. Combination layout, fixed position layout, also known as project type. Group layout or cellular layout. Process layouts are layouts that group resources based on similar processes or functions. This type of layout is seen in companies with intermittent processing systems. Process layout is recommended for batch production. All machines performing similar type of operations are grouped at one location in the process layout. Thus, in process layout, the arrangement of facilities is grouped together according to their functions. Process layout is normally used when the production volume is not sufficient to justify a product layout. Typically, job shops employ process layout due to the variety of products manufactured under low production volumes. The challenge in process layout is to arrange resources to maximize the efficiency and minimize wastage of movement. If the process layout has not been designed properly, many products will have to be moved long distances, often on a daily basis. In product layout, assembly line layout, machines and auxiliary services are located according to the processing sequence of the product. If the volume of production of one or more products is large, the facilities can be arranged to achieve efficient flow of materials and lower cost per unit. Special purpose machines are used which perform the required function quickly and reliably. There should not be any backtracking mainly in layout. The product layout is selected when the volume of production of a product is high, such that a separate production line to manufacture can be justified. Not only manufacture, even assembly. In a strict product layout, machines are not shared by different products. Therefore, the production volume must be sufficient to achieve satisfactory utilization of the equipment. Combination of process and product layouts combines the advantages of both types of layouts. A combination layout is possible where an item is being made in different types and sizes. Here machinery is arranged in a process layout, but the process grouping is arranged in sequence to manufacture various types and sizes of products. It is to be noted that the sequence of operations remains same with the variety of products and sizes. In fixed position layout, project type layout, the material or major components remain in a fixed location, and tools, machinery, men or other materials are brought to this location. This type of layout is suitable when one or a few pieces of identical heavy products are to be manufactured, and when the assembly consists of a large number of heavy parts, the concentration cost of transportation of these parts is very high, as in ships and airplanes assembly, or even in railway coaches. Group layout or cellular layout. There is a trend now to bring an element of flexibility in a manufacturing system. It is called flexible manufacturing system as regards to variation in batch sizes and sequence of operations. A grouping of equipment for performing a sequence of operations or family of similar components or products has become all the important. Group technology, GT is analysis and comparison of items to group them into families with similar characteristics. GT can be used to develop a hybrid between pure process layout and a pure flow layout called as product layout. This technique is very useful for companies that produce variety of parts in small batches to enable them to take advantage and economies of flow line layout. This is most common nowadays. Mass production days are gone. Nowadays it is batch production but high variety. So GT is very useful. The application of GT involves two basic steps. First step is to determine component families or groups. Second step is in applying group technology is to arrange the plants, equipment used to process a particular family of components. These represent small plants within the plants. The group technology reduces production planning time for jobs. It reduces setup time. Thus, group layout is a combination of the product layout and process layout. It combines the advantages of both layout systems. If there are M machines and N components in a group technology layout, the M machines and N components will be divided into a distinct number of machine component cells groups such that all the components assigned to a cell are almost processed within the cell itself. Here, that's why it is called a cellular layout or modular layout. We can keep on adding modules later also. Here the objective is to minimize the inter-cell movements. The basic aim of a GT layout is to identify families of components that require similar of satisfying of all the requirements of the machines are grouped into cells. Each cell is capable of satisfying all the requirements of the component family assigned to it. In group technology layout, the objective is to minimize the sum of the cost of transportation and the cost of equipment. So this is called as multi-objective layout. Motion studies and ergonomics considerations are important in establishing a flow within workstations. Flow within workstations should be simultaneous, symmetrical, natural, rhythmical and habitual. Basically, the flow should reduce mental eye and muscle fatigue and strain. The flow pattern within departments depends on the type of department. In a product and product family department, the flow process follows the product flow. In a process department, little flow should occur between workstations and departments. Flow between departments is a criterion often used to evaluate flow within a facility. Flow typically is a combination of the basic horizontal flow patterns. An important consideration in combining the flow patterns is the location of the entrance, receiving department and exit, shipping. In the facilities layout problem, the decision regarding placement of the machines is typically made. Depending on the application and availability of space, the machines are placed in one of the following patterns: straight, U-flow, serpentine. This is in horizontal this thing. Sometimes if the flow is between various floors in multi-story buildings. When designing a process layout, as I said before, there should not be any backtracking. The most common tactic is to arrange departments or work centers so that the cost of material handling is minimum. For this, departments with large flows of parts or people between them should be placed next to one another. That is called as relationship between the departments. Material handling costs in this approach depends on the number of loads or people to be moved between two departments during some period of time. The distance link cost of moving loads or people between departments. Cost is considered to be a function of distance between departments. The systematic layout planning, shortly SLP procedure, preparation phase. The following tools are used in the layout preparation phase: graphic and schematic analysis. Perhaps the most common layout planning tools are templates, two-dimensional cutouts of equipment drawn to scale, operation process chart (OPC), operations and inspections only, flow process chart, operations, inspections, transports, delays and storage, multi-product chart, from to chart or flow chart. An activity relationship diagram (ARD) shows the desired closeness of departments and areas within the plan. It reflects the fact that all important relationships. Step 3 consists of using the information generated in the previous two steps to prepare a string diagram. The movements are tracked with the help of a string. That's why it is called as a string diagram, showing near optimal placement of the facilities without considering the space constraint. The placement is done by trial and error. Usually the areas with an A closeness are shown first and are connected with the flow straight lines. Then E. A is the high relationship. E is the last one. Then E with the 3 straight lines and so on. Step 4 may be called adjustment steps. Here the adjustment must be made for space needs as related to space availability, so the space requirements have to be determined. This can be done through calculations, adjustments of past areas, intuition or estimates. Once these space requirements are known, it is necessary to consider the space available. In some cases, since the layout must fit on an existing building, the space available is highly restricted. Summary now: decide the optimal location, plan the buildings and allied infrastructure, decide the plant layout with the due weightage for the material handling system, decide the flow between departments. Some key points to consider are flexibility, future scope for expansion. As much as possible, plan the best possible depending on budget, management strategies, etc. As mentioned, once a site and layout are decided and executed, it will be complex and cumbersome to make any changes later, more costly also. Multiple computer packages are available for preparation of plant layout like Craft, ALDEP, etc. Debates, discussion on topics like this can go on forever. Anyhow, let me call it a day. We'll meet again real soon. Some of the statements, views expressed are solely mine based on limited knowledge gained over 6 decades. Always watch these videos with closed captions, subtitles for absolute 100% comprehension as per sincere recommendation zillion times so far. I know I rushed through to complete the presentation within 20 minutes max, which is not possible nowadays since I make honest attempts to cover so many intricate details referring a wide variety of sources, in particular Wikipedia quite extensively besides articles and books published recently. In addition, I add my own salt and pepper and masala based on my personal experiences so far in my life and also intuition. Stay at home as much as possible to maintain social distancing attributed to pandemic novel COVID-19 and prolong your lifespan, lead a healthy life. God alone can put a stop to natural and unnatural events, maybe biowars, however, events like pandemics that may lead to apocalypse and extinction of all sentient species on earth for no fault of theirs. All the best, rest in peace and harmony.